Then on top of this, yeah, okay. Here, now this is based on normalized PCXO
చూడు లైవ్ వస్తుంది చూడు లైవ్ వస్తుంది
and 24-bit ADC. Competent and best minds to tap into. So that software is there. Now all this is actually controlled through text. Video. Then there is logging, scripting, spotting. Hide this itself. You don't have to, ICs, you need FPGA, you need and there's also some breadboard if you can see here. And is there something? Now, next is but this so anyhow, that's for ZBTEX. I think we have. Of course, SSD, AM, FT8, CW. the professionals call it ook. I don't know. Yeah.
By texting or by
Every way. Texting.
macro.
सर ఎక్కడ
Live. Yeah. Mobile. USB-C. Right. So I put this. So it's actually very small. Everything is there. And this prototype. I'll tell you why I'm not adding. So it's best to operate this on battery. Yeah. Yeah. Okay. All right. We'll take. Yeah.
Hello. Hello. Hello.
Live already. So many people are waiting. Just announce within 10 minutes the session will start. Yes.
Hello. The session will be starting soon. Please join.
Introduce you guys and it started. So you're from Bhopal, he's from Mumbai. Yeah.
All right, thank you folks for coming back. So now we're going to have a talk on an automatic satellite tracker built by Sunil VU2 UKR and Manu VU3 BJW, father-son duo. So I'm pretty sure it's going to be exciting because they've written their own software and everything is done right from scratch. So without further ado, I'll put the mic on to them and I hope you guys enjoyed the talk. Thank you.
Thank you, Raghav. Raghav, I need help.
Yeah.
My ex-wife is waiting for the session.
Okay.
So, can you?
You go ahead. Put it on here.
Yeah.
Yeah. Okay. Fine.
ചെയ്യാൻ പറ്റുമോ? അത് നേരത്തെ നോക്കാൻ പറഞ്ഞു. So something should be there for a home brewer.
Is it a
Home brew.
how much weight?
Even my house will rotate on it. Yes.
You are in Delhi or in
No, I shifted to
Kerala?
Bhopal. Bhopal.
Bhopal.
Yeah.
Bharati, you've gone to the middle of the country. So on the end.
Click ചെയ്തപ്പോൾ കൊടുല്ലേ. Good afternoon, everybody. VU2 UKR. Handle is UK and QTH is Bhopal right now. Earlier I was in Delhi. I'm from Kerala. I roam about, and I feel like Lamakaan is the best place to show off any homebrew activity. So I'm here today. I'm a proud father who has my son with me, who helped me in this project. I started this project in 2018, and I have never seen a rotator, azimuth elevation rotator so close. I've seen on somebody's mast. So these things made me crazy. Like, if you want to go to have access to satellite with handheld, there are a lot of hiccups. Like those who have done, how many of you have tracked satellites with hand or with? We have a couple of people, so I can actually go on with what people will understand. So there are technically a lot of issues, and we are a family of hams. I, myself, my wife, and my wife only goes on satellite. She doesn't want to go on the local. Now we are in such a place in Bhopal, surrounded by 11 kV lines, huge buildings on the sides. Now our only option is satellite. Now that is the reason that I revived this project. This project really stuck up with some rotational issues like 540 degrees. The maximum usually the rotator goes, and some of the angles of the satellites were typical when it crosses over. Those who have done satellite tracking, when the satellite goes from, say, the west side, crossing the north towards beyond 90 degrees, there's a hiccup. There's a satellite signal loss because the the rotator cannot rotate more than 540 degrees. 450 degrees. So that way I thought that I'm lost somewhere. I thought about a lot of things and searched for a lot of protocols, and I ended up with my own protocol. So I knew that there's a possibility for a homebrewer to do it. Technically, if you go and buy, you can tweak the original thing. Either you lose the warranty or something like that. So best way was software. The technical hardware solution was limited. Hardware was with me. I built it, but then I got that this kind of a protocol. If I make such a protocol, and with that protocol, if you have such kind of a data, the data should be processed earlier than the satellite approaches, and that is fed to the antenna, and the antennas can then, the software can sense how the path is, and then according to the path, the 450 degree thing, you can invert it. That logic came to my mind, but I'm a software engineer by profession, but my skills were limited in that case. There came the advantage that my son, who was doing engineering in SRM, I told him that this is my challenge. So he took up the challenge. In the fourth year, what he did is, he took the challenge as a project. He presented that project at SRM, and that project was presented at IIRS in Dehradun, and he got a gold medal for that. And that actually inspired me that I can go ahead with the project. And after he initiated that thing, I thought that that's a good way that I can put that same logic into my thing, so that I can make my rotator work perfectly. So is the thing. I'll start the presentation. This is a totally homebrew project, homebrew software. So entirely that a homebrewer will enjoy. Now the thing is, the solution is use an automated azimuth elevation rotator. Now the thing came is whether you will buy or build. For a home brewer like me, that's out of question that I'll go for a commercial one. Definitely I will first try myself. If I fail, then I'll think of a commercial thing. So these are the main things. You know that it's a very costly affair getting a rotator from abroad. about 95K or to 1.5 lakhs is the landing cost of a. So I started this project in Kerala. I went for a vacation in Kerala, and there I met no one other than a welder. I told him I want a thing like two wheels that should work like this. Where can I get it? So he told that these are the options. I told that that's very costly. So we went to the junkyard, scrapped all those things, scrunched for things, got whatever materials, made that roughly 90 degrees, and I wanted to make sure that the thing works first. Rather than going for technical things and accuracy, I wanted to make this as a project, that a prototype which will demonstrate it can work. After that, I knew that things are much better with if you go for high-end motors, stepper motors, very high accuracy. But when I looked at the cost per motor, 8,000 rupees, power supply is even costly. And that way I thought that for a home brewer, very best way is that look for ordinary things, first make it work, then if you want, you can just add on things and go ahead with that. So that was the idea of going for a home brew. So we came up with this project. The project I'm using is currently with, most of you know that Arduino Mega, and there's a supporting two microcontrollers for azimuth and elevation. One is I'm using ESP32, and one is Arduino. Sorry, it's a Node MCU, because you can use any microcontroller for this supporting things. But I chose this at the last moment. About a week ago, I changed these things because I was coming to Lamakaan. I wanted this thing to work differently, not like a azimuth elevation rotator. This was my aim, that if I come here, I should be able to present something the newcomer, the hobbyists, the students, because I know that people who come here really are into technical things. So I'll give an opportunity. I made this thing in an open thing. I've put it on a demonstration at the hall, and you can see it. And the main idea was to present this antenna elevation rotator. That's for the people who track satellites. And the same thing, the DXS. Now there are a lot of softwares. Now this software, this antenna rotator can be used for local communication as well, for VHF, HF, or whatever. You can just remove the head part, you can use it as a normal azimuth rotator. And you say that, why? And here is that we have something into this, a Wi-Fi connectivity onto your mobile. So if you want to rotate your antenna like wherever you want into a 360-degree angle, you put it in your mobile, the antenna will rotate there. Now this is not a fancy thing. This is already there. Now you know, most of you will know about grid squares. How many of you know about grid square, maidenhead? Yeah. These are actually, the globe is divided into different sections. Means like postal codes. These are actually grid squares representing the latitude and longitude of each place. So Lamakaan is having, means this area is having, Hyderabad is having a different number. Delhi is having another number. In Delhi, a lot of numbers are there. Means it differs according to the area. And if you know the area, what this software can do is, on the mobile, you say, you are in Delhi, if you are sitting here, you put ML88QO. That is Delhi, somewhere in Mayur here. What this system will do is, it will automatically point the antenna to Delhi. You need not know how much degree it is. It will automatically point the antenna in that direction. So if you know, if you are logging somebody and you are later on working with somebody, just put that maiden head locator onto your mobile phone. Your antenna will be pointing to that direction. And similarly, I was trying something even new, but that failed. It's failure because of I didn't get time, because it's last 4 days I was trying this to achieve. and I achieved only two things. I brought it here, and that is that sale. Sell it now. It's a prototype right now. So the thing is, like, if you are using these kind of things, you need something new. That's why. So I'll come on to this. So this is a circuit I have currently assembled. I made it in such a way that I didn't put it in a box. I never do that, because if you put it in a box and make it so fancy thing and bring it here, nobody will understand what is inside. And I usually wanted, if I go for some exhibition, I try to explore things, see it, understand it. So whatever I make, I thought that I'll also make the same thing. I'll put it in the open so people who are into this can really understand the project. This is the mobile UI, where you can track the satellite. You can set it which degree you want, and just say rotate, you will go and rotate there. And this is the software. The software part which he has designed for tracking, the satellite tracking software. The entire thing which he has designed, that's also being displayed today. And this is our test on the rooftop, how we tested the whole setup on a tripod. So I'll come back to that. Any antenna, you can put it on any antenna, because it's so rugged that even say about the 300-400 kgs it can even handle it. Only thing is supporting load balancing should be done, because it's made of MS, and this project I actually made for a lifetime project. Like if you want to go for moon bouncing and other things in a later stage, if you are into that, you need arrays, huge arrays. Then if you are building an antenna, you build the structure first, build the basement pakka, that after that later on you can not regret that you didn't make that day. So I made it so strong that even multiple arrays can be handled in that. So I'll just go for the basics, because a lot of you may be new to this. There's something like for tracking satellite you need azimuth control and elevation control. Azimuth control is actually like a person standing here, the circular portion, the rotation will be the azimuth, and the angle which makes on the top will be the altitude part will be the elevation. So while tracking the satellite, if you are tracking LEO satellites, low Earth orbiting satellites, the angles will be definitely changing, the speeds will be definitely changing for each path. The angles will be changing according to the time of the path. So this is the diagram which represents the AOS and LOS. In satellite terms, AOS is the arrival of signal, when the satellite actually just comes above the horizon, and LOS is just setting of the satellite on the horizon. So these technical terms we use in between. If somebody wants, you can note it. So basics is that the satellite tracking software is basically dependent on the Keplerian element, the two-line Keplerian element, which we can get from let's say SatTrack or a couple of other online sites which keep these two-line elements ready. That this is a satellite information, the basic satellite information with which you can track any satellite. So this is a commercial rotator. This is the top portion, this is the bottom portion, and this is the one which is mounted, and this is just for an example I put it. So I'll tell you about standard passes. Standard passes are the passes which generate leak from say after 0 degrees and following up to 360 degrees. This is a normal pass which is easy to track. If it starts from 15, the green one is AOS and this is LOS. So it's easy to track. Similarly, a satellite coming from say after say, 200 degrees going to 330 degrees. So a normal pass, easy to track. These are overlapping passes. These are the difficult ones. These are not the difficult one, like if you are tracking with a hand, it's easy, but there are some limitations. That limitation I will come back to you. See, this is coming from, if your antenna is rotating like this, it's coming here at about say 215 degrees, then it's going up, and then after reaching zero, it's again looping back. It's looping back here another 30 degrees, 30 or 35 degrees. So this is actually the point where the cables start dangling. This is one of the problems which I face. For small rotations, it's okay. Here also you can see that it's passing like this. It's passing the north, it's rotating and then coming back. So this is a point where I started feeling that the antenna rotator is simple to say. This is the point where people get stuck. That is the point where people drop off this project. And that is where I also got stuck up. See, for normal satellite it will work. ISS, because usually I used to track ISS, the easiest one to track, the International Space Station. In International Space Station, usually the satellite, what we call it as satellite, it moves from west towards east. And the passes are like that. Sometimes the passes will be like, say from 315 degrees crossing to say about 90 degrees, or sometimes coming back to 105 degrees. It's past 450 degrees. That's the point I made my mind that if you make something, you have to make it perfect. So that perfect took me so many years. So this is what I said, the standard rotations have 450 degrees azimuth rotation. Issues arise with satellites requiring seamless tracking across north. This is for people who want to note. There's tracking gaps happen in certain orbits, not all orbits. Tangle wise and when azimuth rotation exceeds the limits. We come back to the problem where I got stuck up. This is the one angle I got stuck up, and I sat many days following this map, the type of map on Orbitron. There's a software Orbitron where you can simulate this path. So I sat with this software for, I can say, months and months. When I get free time, I sit with this. I see how it is moving, why this is happening, what are the angles happening. Then I found that there is no satellite going at 90 degrees. I'll tell you, whoever wants to note it, there is no satellite going at correctly 90 degrees above your head. Means the tracking software will give you a 0.1 degree. That is the trick. The 0.1 degree is a gap that will make you understand which horizon, which path, like if the satellite is moving from here to here, if it is say moving at 90 degrees, it is 89.9, it will be like this. So you know that it will be going through 0 or it will be going through 270 and here. That is the point I got, that I needed software which gives data in a particular protocol which can analyze the movement of the satellite beforehand, so that I can set my rotator accordingly, flip the direction of the software, means the path on my software. That's where I got stuck with that, and I had got the help. And we actually generated that. That protocol is simple. That protocol has nothing, because I went into analyzing on the web where I can get Yasu, other thing, azimuth elevation and basic things they are sending onto that onto their USB serial data. Here what we are sending is, you are sending azimuth elevation, satellite name, that's for our purpose, and AOS, maximum elevation, and LOS. And what his software does is, his software predicts the path in which it will be arriving and which it will be moving, whether it's a clockwise direction first and an anti-clockwise track, or it's a clockwise setting to the AOS and anti-clockwise tracking onto the satellite. Because it's a tricky thing. It's a very tricky thing. Those who have tracked the satellite will definitely know. And So with this software, almost all types of satellites can be tracked, because when we have this kind of a protocol, we can track any. We are not into that, like tracking into the geosynchronous satellites which have with slight movement. We are not doing that, because here we are not into precision, because we are into homebrew. Because see, if you have a software like this, you can go into precision, but the hardware doesn't support it. The right amount of work has not gone to that, because we have a 1.33 degree precision right now, which we done with a low cost thing like a laser pen. The laser pen we have put as an encoder. That is the encoder. So if you put two of those, and if you put it as a quadrature encoder, we get it as a 0.66, means greater than 1 degree resolution. We have done that, we checked it, but it's not easy to carry all this stuff, so we dismantled all those stuffs. We have made it simple so that it's easy to, because it's hard to assemble at a short time. So it's a 1.33 degree resolution right now. So this is the main thing of this particular session. This is what I derived from sitting hours and hours onto that software, Orbitron, and derived that this is the thing. Like most of the satellites go like this. Some satellites go like this, starts from after 180 degrees and switch over, like it comes to 135 degrees. So this whole thing is not achievable in one go. You can have one system. You can go rotate and rotate. Means your wire is going to twist. Your coaxial cable is going to get damaged. The next option I found is having a Raspberry Pi. Put a battery. I tried even that. Put it on the elevation part. Put it on a TCP server. Get data. But that's only for weather satellites and all. For communication satellites, or you want to put a repeater there. That's not possible. So the only solution was achieve the flip. This and this, the both on a single thing, not achievable by a hardware. It is not achievable by hardware. The only option was software, for which the software was done. The whole software was designed by Manu, and that gave me that support for this project. This is the trick. One is the rotation from 0 to 360, and from 180 towards 179. Now I pass on to Manu, who has done the software part, to explain in whatever simple way. He's too technical into it. He was actually afraid to come here to speak in front, because he speaks in totally software terms. I call him a paper ham. He publishes papers, not on the air.
Thank you. So, as explained by my father, software was the solution for this particular hardware problem. So, a gist of how we are solving that software problem is by sending and predicting the data before the pass itself, so that the device aligns itself beforehand, so that it can achieve the flip which was explained before. So, we are technically making the machine prepared for the tanglement or any other pass issues that can be faced. So, the whole software is a RESTful service. It's based on Python backend and uses a library which Orbitron also uses. It's called Skyfield. Skyfield is a derivative of PyFM. So PyFM is a C-based library. It's a very old library. It's used for astronomical predictions. So what PyFM does is it acts on planets. So what we achieved here is we treat the satellite as a planet. So once we do that, we get a coordinated system with time where the satellite is going to be. So time is the correct measurement here for predicting passes. So Python has that Skyfield library which uses the thing, and the precision of this software is 0.1 second. So we can get data per second to be able to make the device very, very, very precise. So if the hardware can compensate, so the whole device can be industry standard. And we are using React for front end so that we can use it on phones and any other device. We can host it anywhere. We can use it with our local devices, anything. We are using Redis for cache distribution. So this data which is being created by Python backend, it's 2 lakh data points. So handling that with normal variables is going to be very, very difficult. So we are using a caching mechanism which temporarily stores the cache into the computer and then reads it according to the time of event and sends it to the device. And we also have an additional feature of WebSockets to make this whole thing wireless. So I'll give you a demo of the software. So this is how it looks. You can give the name of the satellite. I can allow a lot of satellites. I can go for HEO satellites, LEO satellites, and polar orbiting satellites. I have right now restricted some of the satellites for the demo purposes. I can click on, I'll show you the actual demo now. So we have a drop down here which can choose which satellite to track. So let's suppose we are going to track ISS today, and we can set the refresh interval. So how many data points do you want per second? So right now we are going to get one per second. We are going to get the position of the ISS. So we'll one second. Then we can go put grid locator or a Google Map location too. So we are going to put MK97FK. This is Panchagota. This is grid locator of this place. I'm going to click on Maidenhead. Today's date, end date can be 15. Then we can do get passes. So what this does is it on the back end calculates the ISS position based on the grid square and time given. So instead of looking and predicting passes on Orbitron and printing that onto Notepad, what we did is we visualized all the passes onto the screen. So we can choose which particular pass is going to be the pass for me and which is going to be I am tracking. So you can see the AOS, LOS, max of all the passes, the visualization of all the passes, where it's going to be max. Yep. So let's suppose if my time is correct, yep. So right now it's 15:05. There's a pass at 15:58. If I start the data streaming with wired mode, which is a serial mode, we are going to send data to this device. This is a mimic of the actual demo which we have set up in the auditorium. So you can see this data being sent over to the device. So once we start the data streaming, you can see it says wait for 167 seconds. So after that, the data streaming will start. In the meantime, you can also see the frequency of ISS, which ones are the active, which ones are the unknown frequencies. Plus, you can also see the time and event details of AOS, LOS, and MAX. So I'll just move ahead my system time so that I can show you the pass. So once we are at, you can see the system tracked ISS since the time is matching the LOS time. Now this will be sent over to our device here. Yeah. So we are mimicking the pass right now since there is no real-time pass available. So we are mimicking this pass. So this also can be achieved by wireless modes, but I didn't prepare that for the demo. It's done over WebSockets. So this ESP can be on a device on the terrace and it should be independently powered.
So this WebSockets is implemented in
Yep.
oh wow.
On a ESP32. So we can, this will start tracking the satellite. It'll go to the max. It'll send data to the rotator. Rotator will do its PWM signal mismatch and all of that. Then it will end. The pass will end. So the rotator will know, okay, the satellite has ended. So we'll go back to the reset position or something. So in the back end, if I may show you the back end of what this data is being made of, you can see we are sending data through WebSocket to the React server, and we are sending data to the serial server.
That's in a JSON file.
Yeah, in a JSON format. And this is a custom protocol which we have set for the device to read the coming data and encode and decode it. So, yep, that's the software. And you can reset it and go back and predict again and put for another pass or something. Yep. Okay. Yeah. My dad will tell you how the laser encoder works for azimuth and elevation gear wheels, which is a very important part of this thing because we need to track where the system is going. So, over to you.
This is the simplest part. With this is the simplest part, I mean that encoder. This is a gear wheel. This encoder was not designed for this. This actually came out of error. I went for staging parts. Got the car power window motor. The car power window motor has a different gear mechanism. So it's a smaller thing. So I need to drive this elevation part. So because I'm not good into mechanics, so whatever things I see, I feel, and go to workshops, see what they're doing, and I got that I can do it. I made it first. I made this wheel. This is the wheel, gear wheel, with these teats. That was to drive directly from the car power window motor, and it worked, but it was not taking the load. So that was initial. At that time there was no encoder. I just wanted to drive this thing and see that the elevation works. So it worked, but it didn't take the load. Then I thought that what's the next possible thing? I went to the auto rickshaw power window, that wiper motor. That also didn't work. There was no power in that. Then there were a couple of friends in Kerala, mechanical engineering workshop friends, and contacted them to go for Leyland Dost. That vehicle has a dual wiper on a single motor. That will give high torque. I chose for that.
You told something about Leyland.
Yeah, motor. The wiper.
You told something about that particular motor. Can you repeat it?
Yeah, I first tried the motor with auto rickshaw. That didn't give that much power. The torque was not enough to drive that elevation. Elevation works, but with the antenna fixed, I'm not good at that particular thing, mechanical part. So I did trial and error. So first I tried, but everything works. The problem was that the load was not being taken. So then I contacted my friends who are technical into automobile, and I told that this is the thing I want, this is the thing I want to achieve. The problem is the torque, it's not taking the load. They told that you go for Dost, the vehicle's name is Dost, a Leyland mini pickup or something like that. It has a dual wiper on a single motor. So it has got a higher torque. So that way I stanched for that, didn't get in Bhopal. Then I went to Kerala, got it from there. There's a lathe friend there who does the power. I don't do anything in Bhopal. People will do anything. You go to a workshop, aap lao, we'll do it. We will do it. They'll just operate it. They'll do anything. They'll not come up with. The main problem is my Hindi. I can't speak that much to make them understand. The problem, I can talk in Malayalam very well. I can talk in English or Hindi. Hindi is a bit weak. So whatever I try to make them understand, they make something else. So whenever I go to Kerala, I make it. So the person there in Kerala is a very technical person with the lathe, so he can understand precisely what I require. That's where I cut the wheels for this. So this is the wheel. This is the wheel. And what I achieve as an encoder is put a laser beam here. The laser, you can see this red spot. There's a laser passing through this, and there's a photo transistor here. Even in daylight it's working okay, but this is not the ultimate thing. This can give errors because if the light is falling on there, but this is for the demo purpose and cost effectiveness. You can put a optical encoder here. There's something called orange optical encoder which gives a high resolution, but the cost goes up. That's why I didn't try that. So I thought that first let me finalize the design, then slowly you can go. So this wheel became a spare when the first wheel didn't work. Then I went to another kind of drive that was with the drive from a bike, the chain and sprocket arrangement. So I change the small sprocket part into a motor from a wiper motor. The wiper motor will be driving the small sprocket of the bike. The main wheel will be driving the main spindle, so that it gives more torque and easy to operate. And on that wheel, I have put the older gear wheel, which is a bigger one. So it gives resolution. I didn't change that. I kept that because that is giving me more resolution than the newer one. So whenever the teeth gets moving, the laser beam cuts. So this wheel is having 270 cuts. When it's having 135 teeth. For one make and break, the whole turn will take 135 teeth. So what I did, rather than counting 135, I counted the makes and breaks. So whenever the light passes, that will be counted as 1. Whenever the light breaks, it will be counted as 2. So I get double the resolution. So 135 teeth, I get 270 teeth resolution. If I add one more laser and put it at a 1.5, that's at a distance, like not at the second teeth, at a 1.5th part, I'll get a quadrature encoder. It will give me higher resolution, double the resolution, means I get 0.66. That we have done it at our home. We tested it, but it was difficult to bring it here and give a demo. So you can achieve less than 1 degree precision on this system. Less than 1 degree precision is achievable. Even more if you can put 4, but that is too much for this system, so we are not going for that. It's better to go for a optical encoder then. It will give much more. This is the elevation part, this is the azimuth part. So this laser is from top to bottom, it is going here, and the sensor is somewhere here. So this wheel, when this make and break, I hope you must have understood by this time this mechanism. This is a chain drive. This is a bike, pulsar bike, discarded chain which was found in a local workshop. I took it, I modified it, I put a disc here to actually put into the frame, and this is the wiper motor of Leyland. And this is actually, I didn't get the Dost one. I got another one because I needed the thing to work. So I got another one. This I will be using it for azimuth now. This I will be putting the actual Dost motor onto this one, so I get more power. And this is the bike sprocket. This attachment I made in the lathe. You can do it because I am not good into that. This is the power window motor of the car. Power window motor. This is driving the azimuth. Directly it is from here, you can see the teeth. It's coupling here. This is the hardware. This is the main motherboard, I can say, is the Arduino Mega. This is the ESP32. This is actually controlling the azimuth and the Wi-Fi. And this is the node MCU, which is actually taking care of the elevation part. Now, why this much hardware? I failed in my first attempt using Arduino, single Arduino and all these things. I used a lot of interrupts. How? Because I was not good at into hardware. I was not good at onto this. I actually learned this only recently. In 2014, I wanted to work with the rotator. I went to one of our colleague like VU3 Bravo Papa Alpha, VU3 BPA Arun. He has an institute there in Delhi, and I went and sat with the students for the class because I didn't know anything about microcontroller. If you want to learn, you can go anywhere. So I went there. I sat for 2 classes. I thought I guess just get the beginning part, what you say starting, and then I'll pick up. Then I started on my own. The internet access was there. I needed the basics. I got it. Then from there I started. This is the motor controller. This is designed in 2018. Not designed perfectly by me. It's actually a thing I found it on internet. A lot of designs were there, but finally I landed up in this good Curtis Brooks, I think his name, because this can handle forward and backward arrangement. Locking mechanism is there, like it doesn't for switching, and there's a delay. You can put whatever delay it said delay you need, and this is this is for elevation. This is for azimuth, and this is my fuse. This is the car headlamp. Because see, when I'm traveling with this kind of a gadget in the open, anything can happen. A short circuit is perfectly it can destroy anything. I know that I can build all these things. It's a homebrew thing. But only thing is, what I'm using is my rig's power supply. I'm using a 20 ampere rig's power supply for this. So driving these 2 motors for a demo purpose. I don't want to lose that. If a short circuit happens here, I'll get a glow on my bulb, switch it off. So I'll save my SMPS. So, so this is not a valve. This and I don't think people will be able to see this.
On the other screen,
Yeah, this one. This is a 100 watts halogen lamp. About 2 or 3 ohms will be the resistance. So it's good that I can put it. I can just have a simple load difference on my motor and save my power supply. So I think that window will be a perfect one to see, because here, so this is the main motherboard, Arduino Mega. It's controlled. It accepts messages from azimuth and encoding from this motor. From data comes from the PC, goes to Mega. It controls with the azimuth elevation. It drives these motors. This is the antenna which is controlling. This is the motor controller. This is a basic diagram of this whole project. Now I come with this new features, because azimuth elevation motor or azimuth motor rotator is common. So this is a mobile UI where you can set the azimuth, set the elevation, and this is the set antenna to grid. If you know the grid part, where the other person's location is, just put the grid number, it will point, the antenna will go and automatically point there. So these are the add-ons to this. And now, after making this project, now I feel that you don't require a PC for accessing a satellite with this setup. If you have a mobile phone with Heavens Above, all of you know that Heavens Above is a software which you can predict. And if you have the software and you have 2 mobile phones, if you have 2 mobile phones, one person can handle the azimuth, the other person can handle the elevation. Just put it and you can make it mobile. This project can work in a field without a computer. So that advantage I later found out about 2 days ago. That way you can manage this.
there is one more way.
Right?
No, That can connect your radio, that can connect.
Right.
It's a recent thing which I just found it very interesting for your information.
Right. I also, because I didn't know about it, but I had one more thing, that if you have a ESP or any microcontroller, if you have the path software like Madhya design, the whole thing can be downloaded onto a node MCU and take it across. But that we didn't get time to coordinate. He's in Mumbai.
Okay.
I mean, because he came early on 12th, we were here in Hyderabad. In the hotel room, we were assembling the whole thing. We were actually coordinating to make it work. This protocol worked in Hyderabad. We just talked about this. He made the software there. He coordinated this. Actually, one word with Shashi about Lamakaan. And we didn't know. He put our names there. Somebody from Delhi called us. We used to HO, Hotel Oscar, Olman Roy. He called me that your name is there in Lamakaan. I told him, I didn't see that. So you are going to present something here. I told him, I talked to Shashi. Okay, that day I told him, get ready. And actually we didn't coordinate. After that he didn't visit Bhopal, where I am. I didn't visit him. We had just talked on our protocol actually worked in Bhopal. Yesterday night,
I got it by 12 years old.
2020 he got. 20. That was another thing. He was not getting license. Yeah, Delhi, sir. So this whole thing, I have put it on a demo at the auditorium. You are welcome to have a view, and so that I can, because there are a lot of small things happen, like carrying in the luggage is too heavy, and a bit of glitch has happened, but we rectified it. Yesterday night at about 2 o'clock, we slept, making sure that it works. Because carrying this from Bhopal, I was actually not allowed by my ex-wife, who is also ham, because seeing this whole thing being carried, and it's not a good thing, like, it's too heavy. So, yeah. Sorry?
What is the weight of the whole thing which you have?
Sir, I can't lift it. That is.
Because once you do that, you have.
So that mechanism is there. That mechanism is there. The whole nut bolt arrangement is there. The tripod is there. Everything is there. Now, if you want to put it on a concrete base or structure, the fittings are made like that. So, this is a result what we achieved on. It's actually using a normal antenna. It's not a cross Yagi. It's using a normal antenna. If you put a cross Yagi, you will get a better resolution. This was done in about a couple of months ago. This is actually weather satellite which we tracked, so that results can be shown on that. By communication, you can use it easily. This is the location. Thank you so much. It has finished only yesterday.
Okay.
Sure. I told him there will be a lot of people interested into this, because the mechanism, because we can customize it. Because earlier, about 2-3 years ago, I actually tried to contact one of the person who developed the DD software, Dynamic Data Exchange software for Orbitron. Orbitron is obsolete. That's where he got the challenge. When we talked, he told that you are using an obsolete thing. I told you developed nothing new.
Yeah, but today also a lot of people use that.
I also use it. Thank you so much.
Right, thank you very much for that, Sunil and Manu. They say necessity is the mother of invention, and I don't think there's a better example for that. And like he said, that the practical demo is at the auditorium, so in case you guys want to have a look at it, please go ahead and have a look at the rotator over there. And thank you again, Sunil and Manu.
2:30. Okay, na?
Hello everyone, the people who are waiting in YouTube live. Can you wait till 2:25? We'll be starting our session very soon. Thank you so much for waiting. Hello everyone who is on YouTube live. Can you wait till 2:25 for more 3 or 4 minutes? We'll be starting our session soon. Thank you. Two 25.
One, two, three, four.
Okay. Yeah, okay, testing purpose. The next session will start around another 3 minutes, I believe. 2:25, 2:25. A interesting session on LoRa ground station that will be delivered, a technical session by Lamakaan Amateur Radio. So all are requested to wait patiently. It is an opportunity for all of us to know more about this ground station, LoRa ground station. It is an occasion for all of us to know more about ham radio by practically attending and seeing all the demonstrations, right from QO100 satellite communication, SPTX, and other types of equipment. Mobile vehicles are positioned in the ground. You can go and see the performance practically. Now, Mr. Subbareddy just is going to give the live demonstration through YouTube. The speakers are expected to come anytime.
Don't worry about it. Get started when you are.
Right, thank you all very much for joining us after your lunch. I hope lunch was good. So right now we're going to have a talk by Giridhar, VO2 TIO. He's a student at CBIT and he will be talking about Vayuvani, which is a LoRa-based ground system for tracking LoRa satellites. So without further ado, I'll push the mic to VO2 TIO. Giridhar, please take it away, Giridhar.
Hello everyone, I am Giridhar. My call sign is VV2TIO. I have worked upon LoRa based ground stations which can take LoRa signals from LoRa satellites, and my mentor from Germany, Chandra, he has helped me to build up the ground stations. So okay, I think it's fine now. Raghav sir, it's okay.
Okay, fine.
So, like Chandra is an independent researcher. He has worked with lot of things. He has done. He has worked with JAXA, ISRO, and many other things. He is an independent researcher. Now we have Chandra in a call. He is presenting from Germany. So, Chandra, can you hear me? Very lag. It's lag. 10 seconds lag. Is there. You can carry on with the session. Hello? Can you wait a second, Chandra? The voice is coming from the HDMI cable, so which is causing the delay. 1 second.
My name is Chandra. I'm working as an independent researcher here in Germany. I'm working in different fields. The fields that I'm expertise in lunar exploration. And particularly, I'm interested and I'm working on current and future lunar missions. If you have already noticed in the recent months past. ISRO's Chandrayaan-2 dataset, and there have been some, I would say, notable works in the past month. Slim JAXA in the past month. First one who founded the Japanese Slim lander using Chandrayaan-2 data, and simulations of Chandrayaan-2 and 3, and I found the moment when Chandrayaan-2 took a snapshot of Vikram lander. And there was also a bit of simulation involved there. So I worked on that, and the other one would be the intuitive machines. That's also I would say crash landed. Landing analysis in that part, and if you can see on the left side, machine 1 took, and on the right side is the actual image. So you would see quite a bit of similarity between those two. So my work is more or less involved in this area. All right. So before I introduce about Y1, I would like to talk about I would like to talk a little bit about the project and set up some context around it. Mostly the area is around the cheaper connectivity, and the idea is that a lot of communities around the world, they lack stable connectivity, not to associate it with internet connection. The idea is that the stable connectivity is also problematic in many parts of the world, also in Germany. The idea is that there have been a complicated ground infrastructure established, and because of maintenance activity, there could be stability issues in these kind of infrastructures. Satellite connectivity, for example, Starlink, have been proposed or have been used already in the past several months to bridge the gap between these two. But the idea is that these kind of connectivity things are pretty expensive for everyone to use. I mean, it probably will come in some years to India. This has been discussed in the recent times. But even if they are coming, they are mostly controlled, and the penetration to satellite connectivity in this developing world or developing economies are also not prevalent. So there have been many proposals to bridge this gap, and there have been cheaper alternatives that are existing already, and IoT devices. These are cheaper, and they have been trying to bridge the gap between these two. And the idea is that there are technologies like LoRaWAN gateways, for example. These have been trying to use to bridge the gap between connectivity, but they also have problems because these are central controlled. Because there is some kind of central authority that would control these gateways, and there is a problem where these devices cannot or need to have an authority to talk to each other. This has been a little bit of focus in the past months. So the idea is that I've looked around this area. Everything fine? One moment. Okay. Okay, so let me continue. So Y1 is one of those projects that I've been working on that's trying to bridge the gap between the connectivity and then providing cheaper alternatives in the meantime. So one of my major visions in starting Y1 is those three things that I've highlighted here. These are more or less the
the kind of key pillars of Vayuvani. What I want to establish with Vayuvani is that I would like to give a complete control of your ground station to the operators, so that they can control their own ground station and also provide offline capability. What that means is that there is no authority there controlling your ground station externally, for example, via the internet. So there would be you controlling your own ground station completely offline. And that's the more or less idea about those two things. In addition to it, I would like to also start a community where there would be sharing of knowledge between different ground station operators, even in terms of sharing the data that they capture, or write more decoders, for example, for satellite data that they receive, and so on and so forth. So this is the more or less the three pillars that I'm trying to establish by the project Vayuvani. But to talk about Vayuvani itself, so that might be a little bit strange. The idea about Vayuvani, the word Vayuvani itself would mean, it's pretty clear if you are in some kind of context from an Indian background, you would know that Vayu is air in Sanskrit and Vani meaning voice or music in this context. So I'm trying to combine those two words and then create a more holistic approach about capturing voice in the air. Or music from the air. That's the idea behind or reasoning behind the word. So the idea about Vayuvani is it's essentially a LoRa-based satellite ground station project that gives the operator full control of their own ground station to capture or record their own satellite data and then process them. By that I mean they can capture raw data and decode them and then share this data to everyone around them. So this is the idea around Vayuvani. So in a nutshell, if you can see in the picture right there, so you would see there are 3 ground stations. So every ground station has 3 components. I'll get to that. And then every ground station receives data from satellites, and the receiving of data or reception of satellite data is completely legal, or there is no restrictions behind receiving data itself. And there are also restrictions when transmitting data on a LoRa band, but these are locally controlled laws. But reception of data itself is pretty much free. So the idea is that a LoRa ground station has 3 main components, a satellite being one of or a transmitter being one of the component, which is not exactly maintained by Vayuvani itself. And on the other station, you're on the reception center, or let's say receiving ground station, has 2 major components. One is the receiver itself that is connected to the antenna. And if you see in the picture, this is the firmware, or this is the microcontroller that has a radio on it, which is the LoRa module. Typically, this is SX1276 or 8 or 1268. These are LoRa modules that you could get it for really, really cheaper. I think it's like about 800 Indian rupees or maybe less than that. So you have one of those radio module here, and you need an ESP32 microcontroller. And this is connected to an antenna that receives the package directly from the satellite. And what you have is, in this setup, what you have is the so-called controller app. A controller app is an application that controls your ground station. So every time you want to tune your ground station, you send the commands through the controller app, the controller application. The controller application sends the commands to the firmware. The firmware actually tunes the radio to a particular frequency or something related to the satellite. Normally, or typically, a LoRa-based satellite has a broadcast at certain frequency, and it has certain, let's say, LoRa parameters. There are several parameters like spreading factor, bandwidth, encoding word, and so on and so forth. These are specific to a satellite, or specific to a LoRa transmitter. And those things can be controlled directly from the app. Typical workflow would be A satellite would broadcast a signal, for example, send telemetries, here is my battery status. Here is my solar radiation indicators. Here is how much. Here is whatever data that they capture, and so on and so forth. So this is actually the payload, right? And there are also typically telemetry data as well, and there are also payload data. So typically these kind of LoRa satellite transmitted at certain regular intervals. So they keep on transmitting these signals when orbiting the Earth, and one of the ground station would receive, one of the YOA ground station would receive it. And so what happens is that a controller app has several settings, and these are already predetermined settings of both satellites. You can configure via the application which satellite you want to track. And once you tune your radio according to the application, the controller from via the application would tune the radio according to those settings. And as soon as there's a pass over, your ground station would receive the raw packets, and the raw packets are immediately sent through the wire to the controller app immediately. So this is pretty much a real-time capture of packets, but there would be no decoding as such in the ground station itself. And then, as soon as the controller application receives the raw packets, it would start decoding the packet on the fly because the controller application has, let's say, it's been configured with a decoder. Every time there is a satellite passing over the ground station, the raw packets are decoded on the fly as soon as they receive, and then the received packets are saved locally into the ground station, into the controller app. So you can actually go through the received packets on the app. I think Giridhar will show you those things in the live after the session. That's YU1 in a nutshell. No authority, no one controlling your application, just you sitting controlling your ground station by yourself. There's also some question might arise that why LoRa has been chosen, or what is the benefit of LoRa, or what is LoRa in general at all. LoRa is kind of a modulation. There are several modulation. I'm suppose already you know that. So LoRa is a long range modulation. So you could receive a packet, a LoRa packet, over more than 300 kilometers terrestrially on Earth. So it's a very, very long distance. You can receive packets over a very long distance. That's what I mean. And you can receive that packets over long distance at a very, very low power. So typically, LoRa module doesn't consume at all any battery. So you can switch on your ground station for long periods of time. And you can also receive LoRa packets at an extremely sensitive, at extremely long distance at an exceptional sensitivity rate. So as you see, minus 137 dBm is one of those really, really bad signal, but you can still robustly decode the packet. So the idea is that you can receive a packet reliably over long range. If you can hear it, if I start playing this, I hope you can hear it. So what you hear right now is the actual LoRa chirp. This is actually the data is being transmitted over the air, and this is a typical hello world signal that YU1 has transmitted, and this is a way to capture them by GQRX. Hope that was audible. Okay, so this is YU1 and LoRa in general, but the idea is that if you are looking at LoRa or more or less a LoRa-based satellite ground station, YU1 isn't the first. So there have been many projects, and there have been 2 projects that have been already quite popular. If you're into this, and then if you start Googling it, you would see these 2 projects that would be shown up. And there are really great projects, and they have been used by hundreds of developers and hundreds of independent operators. And they are really good initiatives, and they try to help connect people around the world. But they also have their own problems, and they also have their own pitfalls, and they are addressed to certain set of a group of people. Y1 tries to complement that area or that spectrum, for example. So these kind of projects, they're really great when you want to have an automatic control, or you just want to create a ground station and let it be, and then it will record packets, and you could just go online and download your packets, for example. Or you would like to connect to a public mesh, public networks. And these projects work great. But if this is what your requirement is, these projects are great and they work fantastic. I've worked on both of the projects, and they work really, really good. But where Y1 is different, or where it tries to fill the gap, is by taking the control from implicit control to an explicit control. By that I mean you can control your ground station without being connected, and this is to target certain group of operators who want to have a little bit more independence in what they can track and how can they track, and track it privately, for example. And if you have your own set of satellites, and you have your own decoders for those satellites, and you would necessarily do not want to share it, and have more, let's say, a peer-to-peer connectivity, and have just a few ground stations talk to each other without publishing those packets online. And this tries to give you this control. Y1 tries to address this kind of situation or scenario, to have more control over your ground station. You just want to switch on your ground station and start capturing it without worrying about do I have internet on or not? And they have several issues in such a kind of scenario. So this is the place where Y1 tries to fill the gap. And the other thing that I talked earlier about, one of the mission statements is about building a community, which is why I'm here today. I would like to invite everyone in the audience to take a good look at Y1, because there are parts of the project which will be open source coming next year. The firmware, the entire firmware has been written from the scratch, so that I have more control over what parts I then optimize it, and to have a better control. And so the firmware will be open sourced, and the control server, which is the server that's actually controlling your radio. So because the firmware has been developed such that the entire radio could act as an SDR, could act as a software-defined radio. So every part of the firmware of your radio can be configured via simple APIs. Of course, they have their own protocols, they have their own way to control it, and this is what the control server does. I'm going to explain a little bit about it in the later part of the presentation. And there's also decoders that I've worked on, and there are decoders to certain satellites that are out there, and some of them I wrote it myself, and some of them have been provided graciously by Satnox. So I've took those decoders, I've tried to modify them, and these are already published in the Y1 GitHub repository. So please go and check it. And this is something I would like to invite the community to take a look at it, and then develop it, and take the community forward. So one of the mission statement is one of that. So there have been several use cases that Y1 can be used, and one of the very useful use case of Y1, and this has been also used in TinyGS as well, is that there are several universities and student-led projects that more or less deploy their CubeSats or nanosats, and they try to receive the packet from these satellites. This is a great STEM initiative, and they try to they try to teach students on how to capture the packet, how to receive it, how to code it, and so on and so forth. And this has been a very good initiative also for Wani. So what you could do is, because the firmware control server will be open sourced in the coming months, but right now what you have is a ground station that operates completely, and the control server or the control application is published online. So what you can do is you can, if you write your own decoder, or you have a format of the data that the satellite is transmitting, writing a custom decoder is very, very simple. And Wani can take in any custom decoder of the satellite that you're trying to track, and then can receive the packets directly without having to submit to someone and then get it approved and so on and so forth. So you can set up your own ground station, try it, go ahead and then receive your packets directly, and then see if your decoder is working, and so on and so forth. So this is one of the most let's say useful feature of Wani at the moment. The other initiative that I've received so far is this weather balloon experiments. These are also a common, let's say, student-led projects where you have a weather balloon that has been launched, that has been deployed, and the weather balloon has a transmitter, and it transmits different kinds of data, for example, I don't know, atmospheric data or some other specific parameter that the experiment is trying to capture. So the idea right now is that the balloon has a transmitter that can transmit data in lower modulation, different kinds of data. So the transmitter transmits the data by whoever has created this experiment. So it has its own type of payload. So this is common. So there would be ways to transmit the data in LoRa, and there's also a decoder for it. So if you're transmitting, then you would also have a decoder. In those kind of scenarios, you could also use Wani directly to receive the data directly from different kinds of stations. So all you need is a decoder in this case, and also in the last case. So you just need a decoder, and then you can set up several ground stations really inexpensively within a matter of minutes, and then you can start capturing data from your weather balloon experiments. This has been one of the other very typical use cases of Wani. A little bit more hybrid use case in this scenario would be the so-called relay stations. So normally what you have is that you can combine the first and the second use case to create this hybrid communication system where you have one station that is more capable to receive or more sensitive to receive a satellite because of several reasons. Maybe it has a gimbal enabled antenna that could really track the path of the satellite, and it is capable. So what Wani does is it can also transmit the data. So Wani is capable enough or it's been built to transmit and receive data. Reception is more common because it's license-free. You don't need any other extra permissions to receive. But transmission, of course, you need to have a ham license. Of course, it's a ham convention. So a licensed operator can also transmit data that it receives. So this is also one of the canonical use case of Wani. So a station can receive packets from satellite, and it can in turn transmit these packets to several stations around it. And LoRa being long range, so many stations that are around there can in turn receive those packets, and they can also transmit it if they're capable enough. And this is one of the other, let's say, most used use case of Wani. All right, so I've talked a little bit about the firmware and the control app and the control server sometime before. So let me explain a little bit about it. So there are three main components if you open the hood. One is the firmware itself. The firmware runs on all ESP32 variants, or most popular variants. ESP32, which is the Heltec V2 board, for example, and ESP32 S3, which is the V3 board. And there's also another variant called C3 variant. This is mostly, for example, I think Zijuno Shao There's also not popular as Heltec and the other devices, but 3D Xiao, ours is C3 based. So it runs ESP32 and Y1 runs on all of those three variants. As I said before, the firmware itself has been written from the scratch to enable this feature about controlling every part of the firmware, every part of the radio. That means that you can control what satellite that you're trying to receive, what is the frequency, and what are the LoRa parameters of them at any time, and then receive the data directly to wherever you want, wherever the control server is. So this is independent part of the system. And you have the control server, which is integrated into the controller application, but controller server can run independently. So the controller server is a really tiny server that runs on an operator system, for example, and you can tune your radio from the control server at any time, and they have a pluggable HTTP and co-op and then other kind of endpoints where you could use them to tune your radio, and they are extremely optimized. The pipeline has been extremely optimized to receive data directly in real time with less overhead, even on the internet, for example. But anyways. So you don't have to worry if you use controller app. Controller application at this point is not open source because it's been continuously developed and so on and so forth. So controller application has controller server inbuilt. So you just need to download the application on your desktop and start controlling your ground station. If you're choosing the path of open source, so you would get the firmware, which is open source or will be open source, and control server. And based on the control server, you can build your own application. So you don't have to use the control application that I built. That's on the website. You can build your own application. You can have your own custom pipeline. What you want to do with the raw packets, you can have your own extended pipeline to build whatever you want. Maybe you want to send the data over internet or put it on the website. You can do everything with it. So this is the idea about having three different components. But three different components are independent and a little bit modular, so you can use it to develop your own applications built on top of it. Okay, so this is a little bit more abstract way of explaining Y1. So let me give you a little bit more idea about the application itself and how you receive the packets. So let me play this. I hope this is visible. So on the left side, you will see the control application. On the right side, you also see the control application. On the left side, you see the satellite passing. On the right side, this is the dashboard where you receive the data, and you see these are all the satellite passing in real time, and you would see that it just captured node B. Not B2, and then you see the last one was RS512C. This is another satellite that's been pre-configured in the Y1 dashboard. I mean, you will get more detailed look into this dashboard via Giridhar, but this is just to give you an idea on what kind of dashboard you would have and what kind of scenario you would see into. And these are decoded in real time. Let's move on. There you go. Okay, so where I am right now, and then I would like to give you a little bit about the roadmap of Y1 in general. So the idea about is that in the last quarter in the 2024, I mostly worked on feasibility. Hey, this is the idea. Is it going to work or not? This is my major intention was to fulfill this requirement. And then in August, I've discussed about how this could be possible. So this is more or less on the technical feasibility. And the application that currently on the website is the early prototype that I've built in October this year. So you could directly use this. Today, you could download the ground station. You can go to installer.yuani.com and plug in your ESP32 device, and then the installer will take care about installing Yuani onto your device, and then download the controller on the application. Download the controller application from the website, and then start recording packets directly. Very simple. This month, I started testing the feasibility of mesh connectivity. So Y1 in itself is completely private, so you don't have to connect to the internet at all. But the idea is that there have been several requests from the users to operate your ground station from outside your network. That means you need to have your ground station and application together at the same place. For example, your home or where you operate, both a controller and your control application and your ground station need to be connected to a Wi-Fi on the same network. It doesn't need internet, but it needs to be on the same network. That's the idea. But when you go out of the network, for example, you have your ground station sitting in your home, and you go to your school, your college, your office, and you're trying to tune your ground station and trying to record packets directly in your laptop. This is not possible because it's local. But this has been several, let's say, highly requested feature. And in November this year, that is last month, I did a feasibility study on the mesh connectivity, and I'm happy to report that the mesh connectivity works. I can discuss about the mesh connectivity later on offline after the session. But the idea is that every ground station can talk to any other ground station and then send and receive packets with each other, also share the packets to the central mesh, and so on and so forth. That is something that I'm testing right now, and in January 2025, next year, early, maybe in the first or second week of January, I will release a new revamped prototype of this control server with the mesh support. It's being worked on currently, and then there are some positive results, but there are also some bugs that need to be cleaned up, of course. In the meantime, we have under 5 ground stations currently with Yuani. So the idea is that with the help of the community, I would like to increase the ground stations from 5 to 10, at least in the next quarter. And by mid next year, I would like to increase this to 15 ground station, maybe a little bit ambitious. So this is what I would like to achieve with the help of the community. For example, you sitting in the audience can help me achieve this, or by setting up your own ground station, and I will give you full support on that. And by mid next year, I would like to release a more or less completely stable control application, downloadable on the internet, downloadable on the Yuani website for free. Of course, at the end of the year, I would like to have an ambitious goal about having 20 ground station with full mesh support. Every ground station can talk to any other ground station and send and receive packets, and so on and so forth. This is a long-term goal that I would like to see in the next months. I would like to invite everyone sitting in the audience to really think about this, and Girdhar can support you and give you a live demo on that. I'll be available. So we need more ground stations right now, so that you can build your own ground station in less than 1,200 rupees, which is less than 10 bucks, I suppose, or maybe 15 bucks, 15 USD or 15 euros, which is really, really inexpensive. If you want to set up your own ground station and try to listen to whatever satellites, download it, decode it, and share it. And this is, you could do that every time. We need more ground stations, and then we also need more decoders to help the community. So I wrote few decoders for myself, for like Norby 2 and then PicoSats. This is the decoder that I wrote myself, but of course you could write it yourself and share it with the community. This is the idea about Yuani in general. I know it's small, but it's a small start. And thank you for listening to me. I think I'm over my time, I suppose, but I'm done.
So, do you have any questions I think it was a lengthy and a little bit boring session, but I don't want to comment on that. Chandra, can you hear me? So
Yes, I can hear you.
basically, our ground station takes LoRa based telemetries. So Chandra, can you show the case studies of Vayuvani use cases?
Oh yeah, sure. Give me one moment.
Slide.
I will have to switch to.
So I'll take more 5 minutes.
Okay. So,
1 second.
I hope.
Sir?
Is this visible right now?
1 second, there is a question.
What are the steps taken to set up a ground station?
So sir, this is a LoRa based ground station. Okay, so this is a very basic IoT based project. You will need a ESP32 board, one LoRa module and one OLED just to see the status of the ground station. So you can get it in the like you can get it on Robo or RoboCraze online electronic component shops. You'll need an active antenna which can receive signals. It should be omnidirectional or directional also will work. So which can take signals from the satellites. So I'll show you an antenna which I have made, a ground plane antenna. Ground plane antenna. Yeah, sir. I'll show the antenna. Sir? Yeah, you can transmit. Frequency currently there are LoRa satellites working around 430 megahertz only. So only UHF will be not in the gigahertz band. LoRa is for UHF and VHF. There are sat links which can transmit. So you had some questions, sir? Yeah, LoRa satellites are acting as a repeater and also as a broadcaster. Yeah, it will be repeating the LoRa signal. One place to another. Like same, like how voice repeaters at ARSS and Sonate, etc. LEO satellites work, such way. So here with us we have you can see my antenna. This is a ground plane antenna. Quarter wave ground plane antenna. Generally, you might have seen only 4 reflectors below it, right? I have made it I have doubled the number of reflectors below it. It's like a disc cone antenna right now. I think you all might know the disc cone antenna. So when we increase the reflectors below it, we might increase the reception of the antenna. So I use this with my ground station. So I don't know how to show you the setup here. So can I, my mobile phone is connected. 1 second. There are LoRa satellites such as Norby, Resicube, SRO, and Tianxi. Tianxi are the satellites which are Chinese satellites. Mostly those satellites, what they do is they are of some other kind. They have some other payload, but they have included LoRa also as a smaller payload, as it doesn't require much power also. Yeah, sir, they are LEO satellites only. They will be available for a window. Yeah, you can. I'll show you one thing to you. But LoRa requires 30? LoRa? Yeah. Any application of LoRa will yeah, sir, there are around 30 satellites in the sky, more than 30. What they do is there are many satellites which come over our area and we can get it on a period of time. Switch from one satellite to another. Yeah, one satellite in a day, single satellite in our sky, it can come around 3 to 4 times from lower elevation to higher elevation to again lower elevation, 3 to 4 times. Duration will be around 7 minutes, sir. Not more than 7 minutes. UHF frequency. Yeah. So the frequency of working of this 435. 435. Yeah. Oh, okay. Yes, sir. I think the antenna which you are speaking might be VHF antenna because lower the frequency, higher the size. This is UHF only. The size of the antenna is low because it's for UHF frequency. The yeah. When yeah, when we want to get very high latency or very high connectivity between the satellite, we use a Yagi Uda antenna with many directors, 3 or 5 or 7 or multiples of odd numbers. No, yeah, so yeah, you asked a very good question, sir. 800 to 850 megahertz band is a LoRa band only, but there are no satellites which will work at 800 to 900 megahertz frequency. Without any satellites, we can build a ground station. It's possible, but it's not useful. Yeah, and in India, you can use it when you have a ham license. When you have a ham license in India, you can use it. So it depends upon the satellite, sir. There are few satellites, they change their frequency. It comes under 436 Norby like transmits, and there are Connecticut. There is some other satellite which. Huh? 437 is SRO satellite and 400 is Tianxi Chinese satellite 400. So this has a very wide bandwidth. From 400 to 450 it can receive any signal because it's not tuned properly, and I have not even used a nano VNA to make it. So it's very rough antenna. So control. Yeah, they are asking. Yeah, modulation, everything is LoRa. Yeah, you can have a look at it.
There's one question at a time.
So, any more questions? I'll show you the Vayuvani dashboard in 2 minutes. Hello, can I have your attention? So this is the dashboard of Vayuvani. You can see here we have three different things here. Can you see there? So there is a tracker, ground station and packets. So this is an older version. There is a new version which will be released in January 2025. So in the tracker, I think there was a session before the lunch which had a very detailed talk about tracking and with a rotator and all, tracking the satellite with a rotator and all. So in the tracker, you can see all the satellites. There's a delay. So yeah, so in the tracker you can see these are all the satellites which you can track through Vayuvani and TinyGS also. The difference between TinyGS and Vayuvani is TinyGS needs internet continuously. Vayuvani can also work offline. So we have made it that way, and the best thing of Vayuvani is you can use it for your own satellite. For TinyGS you will have to connect and talk with the owner of TinyGS that I need my satellite to be included in your list and all. But Vayuvani, you can upload your own decoder of the satellite. It's called as KSY, Katastruct, and you can give a list of sensor data and all which you will receive like a template, and that's how you can receive in Vayuvani also. So it's this is the second thing how it's different than TinyGS. So you can see there are many satellites here. So Connect IoT, Nobi, Polytech University, many universities launch CubeSats as an experimental setup. So this is where you can control your ground station. I'm sorry, due to some internet issues, I cannot make it online here. So it's currently offline. I'll show you the setup of the ground station. I'll show you the hardware of it. So you can see here there are few options. I don't know you can see it or not. So you can see there is a list of satellites you can see here. So you can connect it through auto, or you can continuously track it to one satellite only. So I'll make it listen. So after that I'll save it. And I'll turn on auto. So when I turn on auto, what it does is it automatically searches for the nearest satellite passing through the ground station, and it will connect to that satellite. So here you can also check for all the decoders it has. SRO is one of the temporary satellite which has flown over the earth for around 3 months. So we have a lot of details about it. You can see there is an Apogeo Pico satellites. It's another famous satellite. Have you ever heard of one new satellite? 10 centimeter by 10 centimeter by 10 centimeter CubeSat it is. So Pico satellite has a size of 1/3 of one new satellite. It has 10 by 10 by 3 centimeters. So it is very, very small. You can receive LoRa signals from that satellite too. Huh? So here you can see there is some lag. I apologize. More 3 minutes. Yeah, sure. I'm sorry.
So what would be the typical use cases for?
Use cases. So I said there are few universities, students and experimenters who want to launch their own satellite in the space. So if you want to take the telemetry from those satellites, you don't need to build your own ground station. You can make use of Vayuvani, and you can just give us the decoder, or you can yourself make a decoder and upload in your own Vayuvani control station. That way you can receive the telemetries of your satellite. This is one of the very famous use case of Vayuvani. Another thing is you can form a sat mesh, like how you can talk using ARSS or other satellites through voice. Using Vayuvani, you can send LoRa signals to another ground stations using satellites as a repeater. So this is another thing. And another third use case is,
What kind of a signal can I send?
you can only send LoRa based signals. Only LoRa at 433 megahertz when there is 433 megahertz satellite going on in the sky.
Any restriction on the bit size of the signal?
100 megabits. It depends upon the satellite threshold. So, like I'll show you the packets I have received. It is from Pico satellite. So you can see you can receive such kind of hexadecimal data. So it's an encoded data. You cannot read it. You cannot understand by seeing it. It will be decoded as a health status of the satellite. You can.
Question, typically an FT8 signal
Okay.
is not even into megabytes. Can we not use it on an FT8 decoder?
FT8 is different, right?
Yeah, FT8 is completely different. This is completely different.
So you can run FT8 on a higher frequency as well, right? The guys who use it on moon bombs.
Yeah, but you have to write your
Any more questions? I'll keep my hardware setup outside. After your session, you can see it. It will be out till 4 o'clock. Does anyone have any questions? Sir?
Lamakaan meet
I didn't get it.
this deck that you showed today.
PowerPoint, yeah.
PowerPoint is available. I'll share it. Of course, I'll share it.
I have one question. Last one.
Yeah.
Suppose if there is a new satellite that is launched.
Yeah, sure. And another thing, I said SRO satellite, right? It's a satellite launched by Space Rickshaw company, and we have one of its maker here along with us, Kirtan Chand. You can stand up. So he is a satellite scientist who has launched SRO satellite. It has received telemetries, like it has broadcasted telemetries from the sky. It has also wished us National Space Day wishes from the sky. It has sent LoRa signals from the sky. It was a 3 months mission. You want to speak something about that satellite?
We're running out of time.
Okay. So, okay, thank you everyone for attending my session. Thank you everyone.
Thank you very much for that, Giridhar, and sorry for the lack of time right now. We're kind of running out of time. So before Giridhar moves off stage, hang on. So Giridhar, thank you very much for presenting at Lamakaan. So we'd like to give you this certificate just so that, as a small sign of our appreciation, we like to encourage people like Giridhar who are very, very interested in technical things, and thank him and Chandra as well for coming online to present this talk about the LoRa ground station. Thank you very much, Giridhar. So yeah, with that said, we'll move on to the next session very quickly by Divakar, VU2 FFW and VU2 DPN. They'll be talking about exploring DMR and digital repeaters. So without further ado, I'll just call upon FFW Divakar and the VU2 DPN on stage. And one more thing, we request that you reserve your questions to after the session so that the sessions get over quickly. Thank you.
Okay. So good afternoon, everyone. And so I'll be talking about DMR. My handle is Divakar and call sign VU2 Foxtrot Whiskey from Chennai. So the subject of this presentation is digital mobile radio, also called DMR. And DMR is pretty much getting popular, I would say, across India. Right now, Chennai, Bangalore, and I think Mount Abu, Delhi, all these places have DMR repeaters. So these places have DMR repeaters, and I am pretty sure that Bangalore and Chennai is very active with nets happening daily. And I can happily say that I do the DMR net in Chennai. So that is a quick picture of how DMR is growing within India. So the objective of this presentation is basically to explain what is DMR, how is it different from analog, and what are the benefits and how easy or difficult it is to operate a DMR radio. Okay, or get into the DMR network. So that is the scope of this presentation. I hope all of you have had a very good lunch and yes, no? Yes. Yes. So good. So then we can get into the presentation. So first of all, I'll start with what is DMR radio and DMR as a format. Right, basically started as a digital format by the Motorola Radio Club, and then it was taken over by the amateurs and used for ham radio also. And the standard was developed by the European telecommunication standards. So these were the people who created the DMR format. And within DMR, we have 3 tiers, tier 1, tier 2, and tier 3. So 1 and 3 is not for us. 1 is basically your license-free format, which you can use in the 446 MHz band. And tier 3 is trunked radio, which more of commercial and corporate licensing and all is involved. So we will not talk about that. What we will talk is tier 2, which is the conventional DMR radio, and covers the licensed use of digital format called as DMR. So this is about a quick overview of DMR. So within DMR, we have 2 different services. So one is basically voice call, which we all know, which we have been accustomed to in the VHF area. And DMR has, apart from voice, data also. You can start sending SMS using your DMR radio. And there are different types of calls which is possible in DMR. In VHF, what we do is we just call in VHF and at an appointed time we conduct net and everybody listens through, etc. So here what is happening is we have something called as group call, where there are various talk groups. A talk group is nothing but something like your chat rooms you would have used in your internet. So all these group calls are possible. So which means that today Bangalore has a talk group called 40480. Chennai has a talk group called 4040454. So what it means is that all the Chennai listeners would be connected to this talk group, and whoever is tuned to that particular talk group can listen to that particular group. So that is what we mean by group call. And of course we have broadcast wherein anybody can listen to that broadcast. I need some help. Can we either get the people inside or probably have them move outside? So to continue, right, over VHF and DMR, these are some of the additional services that we have. Okay, so it's something short of a mobile phone wherein you can do some data also, like SMS, small data also through your DMR radio. This is another very interesting slide where I will be talking about the different modulation or different types of digital services. Now DMR is a format. It comes under the umbrella of digital technology. We have digital radios, and under that one format is DMR, another is if you see C4FM. Now C4FM is provided by some Kenwood and Yaesu companies. Their radios are digital radios. They have, for example, Yaesu has a FT5D DR. Right? That is a digital radio. Now, if you ask me if that can talk to a DMR radio, it cannot. So that is where the formats are different. You know, like the format what we talk about in the Blu-ray versus DVD kind of things, so they don't operate each other. Okay, they cannot operate among them. So similarly, what happens is we have C4FM and then we have DMR, all are different, we have D-Star, all are different formats. So to use a D-Star, you need an ICOM radio. To use a C4FM, you need a Kenwood or a Yaesu radio. And to use DMR, today we have only maximum 2 or 3 companies which provides DMR. One is Alinco, one is Motorola, and then the Bofeng. These are the 3 companies which does DMR radios. So each comes under the digital format, but the format is different. And these are some of the typical parameters of these formats. Like your analog signal is 25 kilohertz wide, whereas your digital is only 12.5 kilohertz. So you can have 2 channels within that 25 kilohertz. So we will see how to have 2 channels in the upcoming slides. So these are some of the parameters between the various different digital formats. Now, the baseline here is that if you want to operate these formats, you need that many radios. If there are 4 formats here, you need 4 different radios to operate in the 4 different digital formats. So that is the underlying point here. Okay, so what is the advantages of DMR over analog? So basically, now that I've been practicing or operating DMR for the last 2 years, I can say for one, the voice quality is absolutely clear. Okay, it is something like your mobile phone quality, if not more. And the other one is the DMR signal has automatic error correction, which is not there in your analog. So what happens is that even if let's say if you're talking slightly in a lower modulation, the sound output that you get on the other side to the other listener is absolutely like 5.9++, and even if there is a weak signal, the signal gets corrected itself because of the bit rates, right? And so the opposite party will not even realize that you are having some issues either physically or on the radio kind of thing. So the signal quality is absolutely very good. And as I said, this is using 12 kilohertz only, so 12.5 kilohertz. So we can have 2 time slots, which we will see in the upcoming slides. And when it comes to, again, we'll see this in the upcoming slides. So we don't need to have any additional setup to talk over a wide range. Like, if you want to VHF, if you want to talk to from Chennai to Bangalore, you need a very big antenna to do that, maintain that, operate that distance. Whereas here we will see that totally the setup itself is different for DMR. So basically the DMR operates through networks. And what do we mean by network here? I can take an analogy to the mobile networks. We have Airtel, we have Jio and so on, right? Imagine if Airtel and Jio, if you have two different phones and if you are not able to call each other, what would be the situation? And that is a similar kind of situation in DMR. There are multiple networks, more than one, all are free networks. We have Brandmeister, we have TGIF, free DMR and so many. Okay, but so if I program a channel for Brandmeister, I will not be able to talk to TGIF and so on. Okay, there are certain exceptions, but invariably this is the baseline for the DMR networks, that one network can talk to the talk groups inside that network. That's it. Okay, if you have to do cross modes, then that is a different, totally different setup. But otherwise, this is the setup. You have a network. The network has many servers across the country, and each server will help you connect to the network. Okay, and I can have as many as talk groups that I am able to create in that network. A talk group, as I said, is nothing but the something like a chat room, so that you can create chat rooms according to your state, city, or interest area, exactly whatever you want. But depending upon the network, if the talk group creation is being controlled by the admins, you will have to get permission to create the talk group. They have to allow you to create the talk group, right? So that is the setup in terms of the network, the server, and the various talk groups that is inside it. So for example, this is just for example, we have Chennai DMR repeater, VU2 Mike Whiskey Golf, which is connected to a talk group number called 4040454. So similarly, Bangalore is connected to 40480. So any people who can tune into this talk group can listen to whatever is being spoken in the whatever signals that is coming into this talk group. So we will see a demo at the end of this session. But this is the how the networks are organized. So it's like the topmost element is the network. Under the network comes a various servers. The servers are there in the various countries, and each server might be connected to multiple or single talk group. So that is how we create we join the networks. So as I said, so talk group is nothing but a room. I have given the talk group IDs of the various repeater, and these are the things that if you program in your digital radio, you can talk to, you can just join the nets, or you can do ratio, whatever, you can talk one-to-one to other digital amateur radio operators. So here there is sometimes a difference between two networks. One network might enable you to create a talk group without a repeater. The other network may not allow you that. Depending upon the size of the network, they put some conditions and policies so that the user, the number of talk groups does not go out of hand. So that is the reason. But otherwise, a general proper usage is that every talk group will have a repeater attached to it. So I think, so this is a simple setup I have shown here, how use a DMR radio and a DMR repeater. So I think most of you will know analog repeater we have almost in every state. Now if that needs to be connected to Echolink, you need to put another setup called Echolink, where the Echolink software runs on a Raspberry Pi. And that Raspberry Pi is again connected to a regular radio, like a handy or a base station. And the base station is again connected to an external antenna. So what happens when somebody speaks, let's say somebody from DX speaks using Echolink, it comes to this radio, exits via the external antenna and reaches our analog repeater, and an analog people who are connected to the analog repeater, they are able to hear the DX station. This is how general analog radio is operating, where Echolink is connected. Now, if you come to the DMR repeater, the DMR repeater on its own is directly connected to the internet. So you don't need a separate setup to make DX happen. Anybody who has a base or a handy which can connect to the DMR repeater will be able to talk directly to even the DX users. So you can do DX sitting at home using your VHF, UHF radio and get contacts on the DX also. But there are various talk groups by country, by state, within the country which you can connect to. So any questions so far? Talk about that, it is there in my upcoming slides. Questions? Lunch was so good. I think there are multiple repeaters in Delhi. I've just taken an example. No, it is I operate. Is a DMR repeater? DMR repeater is on UHF. Okay. I came across only FU1 and I think there is. Okay. Okay. But is that FU1 is a DMR repeater, right? FU1 is the analog. Analog, is it? FU has two channels, analog and DMR. Okay. Okay. Fine. So any other questions? Okay, so I'll move on to the next slide. Now, this is a question that I have been getting for a very long time. I heard from many hands that, the DMR means encrypted signal. I'm telling you it is not encrypted. Okay, it is encoded, but it is not encrypted. The difference is that it is just the formats. I think all of you here will be very familiar with document formats like Word, Excel, PowerPoint, whatever, right? So if you use a PC, we have different text editors there. We have Notepad, we have WordPad, and then MS Word. Each of these software support a specific type of a text file, right? The Notepad will support a text file which is ASCII based. Whereas MS Word will support files which are RTF, UTF, whatever, right? So if you open some other file within WordPad, it is not going to show you the exact results. It will show all some weird kind of fonts, right? So similarly, it is nothing but here all the modulation types that we saw in the NXDN, P25 are all different formats. It doesn't mean that it is encrypted. If let's say, Raghav is talking on a digital radio on DMR and I have a DMR radio and I connect to the same frequency or talk group that he is talking, I'll be able to hear him. It is not that he is encrypting his QSO, but I'll be able to hear him if I have the right equipment, simple. Whereas encryption, even if you have the right equipment, you need to have a certain passkey or password or a cryptographic key. Only then you will be able to decrypt whatever is assume. Now, every other guy who has a computer, if he is hitting my site is going to go down in no time. So what will happen? I will geo-distribute the loads. And that is why we have something called as content delivery networks, what we call in the cloud. So what will happen is, based on the request that is coming, any request that is coming, we will know the geo indicator. Okay, so that based on that geo indicator, it will go and hit that particular server. So the load on a particular server is reduced. So that is why we have this kind of a multiple server setup, and people can connect to any server they want, and load is also distributed. This question, right, I just wanted to take one more point and say that today, let's say my repeater is connected to, say, United Kingdom server. And for some reason, tomorrow United Kingdom server goes down for maintenance. I don't have to do anything. I just have to switch to some other server and my repeater will start functioning again. So that is how the DMR network works. Can you repeat that again? Mobiles connecting to? All the DMR headsets connected to the same. They won't talk to each other. So do they? Okay, so when you have a hotspot, only you will be connecting to it. It is your private repeater. Others will not connect to it. If it is a public repeater, then there will be many people connect to it, just like you do your regular VHFs. Okay, so your hotspot is your own repeater. Nobody else will connect to it. So hope, Raghav, I answered your question. Okay, so coming to some statistics, right? I think, see, DMR again is an evolving technology, just started getting the visibility. Right? See the different states, how much DMR users we have. Okay, Karnataka is leading, and then comes Kerala, and then Tamil Nadu, Maharashtra, and so on. Right? So this is how it is leading, and again from the world over statistics, United States and UK are leading. So there is a lot of interest that is being shown in DMR, and it is contrary to what people think, right? It is very easy to join, operate, and maintain a DMR. Much easier than your, analog, I would say your analog radios. It's very easy. And personally, I would say that this is where you start experimenting, exploring also. There is no, you can write your own software also for DMR. For such apps, right? You can do your own Android or whatever iOS app and bring out some cool apps to users so that they can use. Right now, I know all these free apps that are being, they have something wanting here. There will be some features here, some features will not be there. All that is possible, right? So we can write our own apps also. We can write our own clients for our hotspots. And so it's very much an interesting place to explore. And the another very visible advantage that I say is, like, say if you are traveling, okay, today if you are in the analog space, what you will do is you will take your handy with you, and sometimes what happens that gets into hassles because of some security issues and all that. So the best way is, use your mobile, just connect to DroidStar or some other app and just connect to your favorite nets and rack shoes, whatever is happening around, right? So it's very easy, and DX is also possible. So absolutely, and even I can say that even when you log a DMR QSO, people acknowledge and confirm that. It is not that nobody, does not bother about whether a DMR QSO is getting logged or not. They do, and in fact, all the DX operators, they make it a point that they log the DMR QSO and they expect you to confirm also. I have seen that many of all the, even the experienced people here, they don't know much about the logging part. Okay, even the veteran hams, I've seen certain veterans, I will be waiting for them to confirm. But later when I go to their QRZ page, they are not even a member. Right? So that is one of the, things that we can avoid, and we can definitely log a DMR QSO and get acknowledgement. And of course, all the logging sites count this also for your DXing awards. I just wanted to highlight and underline that point here. So that's about it, and I just want to show a small demo now. Yes. Okay, a typical MMDVM hotspot fully built and assembled unit will cost you 7,500. Oh, you mean the frequency? That operates in UHF. Okay, so the distance will be few meters. See, the hotspot antenna that you have, the hotspot itself is not very, it's not a high powered one. So within the QTH, a little outside of your QTH, you will be able to operate. See, I'll go back to this slide. See, all these hotspots, right? They operate in 5 volts. Your typical Raspberry operates in 5 volts, right? So what happens is you can power this hotspot in your power bank, take it out into the field, use your mobile hotspot as your internet connection for your hotspot, RF hotspot, right? And then you can do DXing from anywhere in the world. You can just carry it along wherever. You can even put one in your car. So that it is that easy. See, what I felt is you will get reception you will get, but I am not sure if you will get a transmission at 100 meters. I don't know if you have tried transmitting, but I have seen that typically transmission, I've gone about say 250 to 400 meters away from my hotspot within my QTH compound. I was able to receive, but transmission I was not so lucky. That's 10 watts, yes, but your hotspot is not 10 watts, right?
No, the TXN.
Okay, your radio 10 watts, I don't know. I have tried it with only my MD5 Alinco radio. I was not successful. Okay, so here I just want to show you a small demo. I'm using an app called RideStar, and right now I have connected to 4040454, which is a talk group inside the Brandmeister network. And you can see I have connected here, it is Brandmeister Netherlands server I have connected to, and I'm going to start a QSO now. Let's see. Respond to him. VO2 DPN Foxtrot Whiskey.
Nice copy, thank you.
So that is as simple as that. You can just use your Android app and nothing more is required. And you can keep in touch with your friends, nets, rack shoes. I find this very, very easy for doing rack shoes. So that is how you can easily operate and use it. So that's all about DMR. Hope today you have got some clarity on this topic. If there are any questions, we can take it now, else I can wind up.
Talk about your budding ham
So, I think about a year back, I started my own talk group, which is called as Buddingham's Talk Group. And this is on the TGIF network. It is on a different network. The reason why I selected TGIF network is the Brandmeister network, which we are all using for repeaters, right? It's huge. They have some 50,000 talk groups. And if you have to create a new talk group, you have to put up a repeater. They don't approve talk groups without a repeater. And we cannot put up a repeater just like that. It takes a lot of cost, right? So TGIF is much smaller network. The full form of TGIF, as you all know, thank God it is Friday. So it is just an acronym that they have used for the network. And relatively, this is a very small network. The total number of users that I have seen as a few weeks back is around 11,000. Now, why did I select this network? Because I can easily create talk group. Nobody asked any questions. I got it approved within the hour. Right? So I created a talk group, mainly reason being I wanted people to join this talk group easily and without any limitation of the equipment or any other constraints that they may have. Because all they need is the available mobile phone. And today everybody has at least two. Right? So, yes. Right star. Select any. You see, the host depends upon which network you want to join. If you want to join Brandmeister, you can select any host. Okay, but put the right talk group ID. The talk group ID, for example, for Chennai, as I told you, is 4040454. For Bangalore, it is 40480. All this you will get it from the website itself. Which talk group, what ID, which location, all that you will get a entire talk group list. You can download it from the Brandmeister network page itself. So, going back to why I created the talk group 735 is basically I wanted people to join and talk at length about technical topics. Most of the nets that we have in our both analog and DMR space is all QRU 73 nets, which is also required as more of a roll call. But I wanted people to come and talk about and discuss their projects and get things clarified. So that is why I created this talk group number called 735 Buddingham's Talk Group. It is on the TGIF network, and I do a net on this every Saturday from 7:30 to 8:30 p.m. So it is very easy to join this network, and you can create an ID just by registering your call sign. I have put up complete steps of what is required to join a DMR network in my blog spot. You can visit that and download the document and then follow the document to join a specific network and join specific talk groups. So that is about the Buddingham's talk group. Any questions? Yes.
No question, just a
We have to program the.
Yes. See, correct. See, what I have not told here is, because I didn't want to get it into more technical, this is more about giving a picture of what DMR is. Everything for hotspots and even for your radio, digital radio, you have to do programming. In the hotspot, you have to load the Pi-Star image, configure it. And in your DMR radio, you have to create something called as a code plug. A code plug is not a big deal. I have mentioned it here. So a code plug. I think the battery is okay, battery. So code plug is nothing but a list of all repeaters, the TX, RX frequency shifts, and talk groups and available, right? All that gets loaded into your radio. That is a code plug. That is as simple as that. You can think of it as an Excel sheet where you list all the repeaters, the TX frequency, the negative shift or whatever shift, and then the particular talk groups in terms of, in case of a digital radio, right, a digital channel. So that is a code plug. I'll show you my code plug for MD5 radio. This is what you see here. For example, is the example of a code plug for Alinco MD5 radio, and I have programmed many channels here. And this 434.5 that you see is the frequency of the hotspot. So my radio talks only to my hotspot, and from there it goes into the internet. So we have to. Yes, you have to. All these are nothing but channels. You see here, channel type is there, and everything is a channel. It has a name. For example, this is India. There is a brand my store India channel, which is having a talk group number of 404. Okay, so you can, once you program this channel, you can talk into the talk group. And I think most of you will know about the CT, CSS tones that analog uses. Similarly, in digital, we have two parameters called time slot and color code. So these two have to be right for your channel. It should be the same as what your repeater or a hotspot is using. So once these are all in sync, then you will be able to make a QSO. So that's all about the DMR format and DMR radio. Any final questions before I wind up?
shack at home. I don't know if you can see it. Yeah, this is my shack at home. And, that's about it, guys. This is all about Q100. Different ways. There's a portable setup, there's a mobile setup, and why go portable? Well, I think it's a lot more fun than sitting at home and looking at the same four walls and making QSOs than looking at different things on different activations. So it's a very small gist, very small talk. Unfortunately, these videos are not working. It looks like some modeling portfolio. It's not. Trust me, it's a video which is not playing. So, any questions, guys? This is just a small 10-minute introduction to POTA and field that I did. Yes, please go ahead.
How many quotas have you done?
I think on record I've got about 41 now. 39 or 41 I've got, out of which some are repeated parks. So if you see the POTA page, it may show about 27 or 26 because some are repeated. And I've got, besides the POTA 40 operations, I've got about 28 field operations, which were not in any designated park code. Like I've operated in the Thar, Negisabi, you know. So one part of the Thar has a park code. The one closer to the Tannod border does not have any park code, but I did operate there with the Army's permission. It was fantastic. And I could hear all the Saudi and Arab stations very loud and clear in that place, to answer your question.
So permissions, whom do you approach for permissions in
Ram, normally if it's inside a designated forest area, I do talk to the range officer there. And I tell him I'm a licensed ham radio operator. I do it at least 4 days or 5 days before I go there, because sometimes these guys say you have to ask their higher ups. But normally it's the range forest officer who's got the authority. He can say yes or no to you. And if you tell them that, see, this is also used in disaster management and it's useful to know whether we can operate from here. For example, the Kerala disaster was very close to our Wayanad station. Very, very close. It was less than 1 hour's drive, I think, from there. So normally they are cooperative, but sometimes, like Mukruti, I've been trying for the last 1 year, is the highest point in the south. In fact, they say Dodbetta is higher, but Mukruti National Park, beyond Ooty, is higher. And that park has been very difficult to get permission for me, because it's the confluence of 3 states where the water stops there, and they have had some natural issues earlier there. So they're very wary about anybody walking around there with even a walkie-talkie in their hand. But I've written to the state government there, the district collector, and explained to him that this is what I want to do, and all I need is about 6 hours there, but I still haven't got the permission. Q100 is always a low power operation. So at home it's 0 or some few milliwatts. But the DX Patrol full display radio is pushing about 4 watts or 3 watts, I think, maximum.
And one more question to add to that. And usually, the line, like on the vehicle, it's a little bit difficult. So we on the vehicle and do it. Like, do you have any tips for that?
No, normally I think whatever I've learned from Saro. He's been great in teaching me this. But it generally works at 259 and degrees and 29 degree elevation, plus or minus. And then that's the reason I have the RTL dongle connected, because then you see the low, mid and the IR beacons becoming stronger and lighter as you turn the dish. So more than digitally, it's more of a visual look-see and hear the beacon. And then you see the dB meter on the SDR, and you can kind of narrow down pretty quickly to it. There are 3 or 4 apps, satellite finder apps, I'll share with you, Negisabia. And you place that on the dish, and generally west, 10 degrees east of 10 degrees north of where the sun is setting, you're there 9 out of 10. 9 out of 10 you're there already. Then you can fine tune once you set it up. it's www.http.pota.in. You can register on that. Joseph? Yeah, nobody wants to come with me, Joseph. I don't know why. When I tell them I'm going for a ham operation, nobody wants to come with me. They don't want to carry my gear. But no, it's normally I go with friends and family, always. And only when I'm setting up my antennas, they're probably in the resort or in the forest park, wherever, relaxing. And I have my SWL, Anand, he's been with me, he's my driver also. So he helps me a lot in carrying my equipment and setting it up. In fact, he knows a lot about ham, and then he should be knowing because he's been spent the last 3 years with me, setting things up with me. A couple of times I've had issues. One place near Chittoor, I mean, it looked very nice and clear, but I had absolutely zero propagation there on any band, and I thought I had blown my radio or something like that. But it was in the trough of a valley, and for some reason, nothing was working. Vertical was working only on 20 meters. And when I shifted the antenna position by about 60 meters to the last cottage, my friend has some cottages there, everything was normal after that. It was just amazing. I've gone back there 3 times, set up the different antennas in the same spot. It's like a black hole. From there, there's something blocking it. I can't figure out what. Probably a close by mountain. I don't know what it is, but including an NFET is very noisy in that particular spot. That's the only place where I've had a problem. Depends, yeah. NFET is always good for your NVIS and local communication. But off late, I've just made a small portable Yagi using 4 whips, and I've had fabulous results on 10, 15, and 20 on it. By far, it is the best, and if you're on the ocean front, nothing comes close to a vertical, I think, if you want to do DX. I think a lot of experienced guys here will agree with me. If I'm wrong, please do tell me so I can learn a bit, because I'm still a very new guy in all this.
You call CQ Pota or something like that?
Yeah, it's CQ Pota, and then you follow it up with park code. Park code, because for example, today's Jalpadara activation is 0101, and it's India November for India, IN. So the guys will be calling CQ Pota and India November 0101. So the minute you say Pota, then you have a lot of guys, or you don't have to be in a park to make a contact with a Pota guy. You can be in your shack and register on this website as a hunter. You register yourself, and then, example, I am in the park, activating a park, and you make a contact with me. You just go into the Pota site, and under your account, you log me there. And you will get credits for that also as a hunter. You're called a Pota hunter then. So it's a very interesting thing, and it's a very nice thing. Yes, so if you're making a contact with me on SSB, I will tell you, for example, 0101 India November, and my call sign. So you go into your Pota app, open the log sheet, and enter operator view to UCR, hunter GRM, park code, and the time you made the contact with me, and the band. And the minute you enter, it will link with the same log I've entered for you. Confirmation. So you will get your points as a hunter, I get my points as an operator. He will get, he can check his log. By logging into his app, he will know that he's been logged by me. He'll get that 100 credit for it. He doesn't have to enter my call sign and say he's hunted me. Minute he enters the logbook, he will see a star next to his thing that he's hunted me there. Yeah. It's a website. It's a website, yeah. It's a website, you log into it. Yes, sir.
Yeah, so have you done?
No, not yet. I'm still on voice. I plan to get on CW soon now. So. Anywhere between 70 and 80 watts. QRP is, yeah. QRP I've got quite a few activations actually, and all are between 3 and 4 watts because that radio gives only 4.4 watts, the 2 SDX. And my ICOM on its own power backup gives 5 watts, as you know. But my lowest has been 3.8 watts to Florida. It's an effort, but if you have good conditions and if you have a good resonant antenna, I think it's as good as any radio. And portable, but motorcycle, yes, and I've operated on the motorcycle. Mr. Negi sitting right in the front. I think we are the first motorcycle to motorcycle QSO. He was in Diu on his motorcycle, and I was 100 kilometers south of Bangalore in forest near Kanakpura. And we were speaking to each other like this, like FM, from a motorcycle. It was an amazing experience, so to say. I'm sure he can also say a few words, Negi-sab, on your experience with mobile and field operations. So, Manpack.
I have not done anything such spectacularly well as Hari, but I do operate from the motorcycle, and I have a whip on the motorcycle, which I fold up and then I open it. I use a G90 Jagu or a FT891. 891 I'm able to use about 40 odd watts, and the G90 around 15 odd watts, 50 to 20 watts it gives that. And it's pretty good. One of the main things is that you can drive out to a place where there's noise. All of us live in cities with apartments with so much of noise. We can't hear anybody, so we are not able to communicate. But out there, if you go like Diu is S0. On the seashore there, S0 on that island, Diu. So you're